Now, monomials come pre-factored into primes. Polynomials, however, are not so nice. Before we can find common multiples of two polynomials, we need to talk about what it means to factor a polynomial completely. To factor a polynomial completely, well, we start by factoring out the greatest common factor. Then, once we've done that, well, we factor the remaining polynomial factor using our various techniques for factoring polynomials. So for polynomials with 4 terms, we'll try grouping. For quadratic trinomials, we'll use the AC method. For other trinomials, we'll try substitution to make them quadratic. And finally, for binomials, we'll see if they're special forms. Again, the 3 special forms of binomials that we know how to factor are the difference of squares, difference of cubes, and the sum of cubes. But we don't stop after we factor our polynomial factor once. Instead, we continue until all of the factors are prime. So let's see an example. Suppose we want to factor this polynomial completely. Our first move is to factor out the greatest common factor. We can see pretty easily that the greatest common numeric factor is going to be 4. And looking through, I see that the only variable common to every term is going to be y. So 4y is going to be my greatest common factor. What's left? 4 times what is 8? 4 times 2 is 8. I'll have 2 u squared x plus 4 times what is 12? 4 times 3 is 12. 3u squared minus 4 times what is 8? 2 again. V squared x minus 3v squared. All right, now I have a polynomial with 1, 2, 3, 4 terms. I want to factor that by grouping. What do I have? I'll have 2u squared x, 3u squared, minus 2v squared x, minus 3v squared. Greatest common factor of the first row, I think, is u squared. Of the second row, v squared. What do I need to multiply u squared by to get 2u squared x? I need to multiply by 2x. Is 2x times v squared equal to negative 2v squared x? No, I need this to be a negative v squared. What do I need to multiply u squared by to get 3u squared? Well, 3, clearly. 3 times negative v squared, that's negative 3v squared. So what do I get for my factors? I have my greatest common factor, 4y, u squared minus v squared times 2x plus 3. Am I finished, or can I factor further? Well, the monomial part, that's fine. 2x plus 3 is prime. It's not one of my special forms. U squared minus v squared? Oh, that's a difference of squares. I can factor that. How do I factor a difference of squares? Well, the first thing squared minus the second thing that's squared times the first thing that's squared plus the first thing that's squared. So these two are the factors of this binomial. And we can't forget our 2x plus 3 factor. Can we factor any further? Well, no. These binomials, none of them is a special form. So we're finished. I'm going to give you one of these to try. Factor this trinomial completely. Pause the video and try this now. Well, we'll want to factor out the greatest common factor first. We'll certainly have a y squared. That appears in every term. The greatest common factor of these three numbers, I think, is 7. Again, this is a place our calculator could help us if we weren't certain. 7 times 2 is 14, so we'll have 2x squared. 7 times 5 is 35, so we'll have minus 5x. 7 times 3 is 21, so we'll have minus 3. We want to factor this trinomial using the AC method. We'll have a 2x squared, that's for sure, and a negative 3. Now we want two numbers whose sum is negative 5 and whose product is negative 6. I think we can see at a glance that our two numbers are negative 6 and positive 1. Both of those are coefficients of x. Remember, I'm splitting up my negative x to the 5th term. Greatest common factor of this row will be 2x. This row I don't see a greatest common factor, so it's 1. 2x times 1 is 2. 2x times what is 2x squared? 2x times x is 2x squared. Is x times 1 positive 1x? Why, yes it is. 2x times what is negative 6x? 2x times negative 3 is negative 6x. Is negative 3 times 1 equal to negative 3? Yes it is. So we have the right factors. We get 7y squared times 2x plus 1 times x minus 3. Now, is this binomial prime? Yes, it is. Is this binomial prime? It also is. So I have factored this polynomial completely.